Okay, so what we are going to look at is operator precedence, and that's again like related to evaluating an expression, and how are we going to use a stack to evaluate an expression. Okay, so in a math class or even in an earlier programming class, you would have written some small program to evaluate an expression. Okay, so let us say this is an expression 5 plus 8 divided by 4. Now, how is this expression going to be evaluated in math? Okay, that's what we want to look at. Now, so there's no parenthesis here or anything in this expression, so that means we need to break the tie, or we need to say which operator is given precedence or more importance compared to some other operator. So here in this expression we have plus and division symbol. So we need to know whether addition has more precedence or importance compared to division, or vice versa. So in maths or even in digital logic, you might have come across that we give more importance to division compared to addition if an expression is something like this, where you don't have explicit parentheses. So that means we'll do 8 divided by 4 first, which is 2, and then do 5 plus the result of the division, which is 2, and the final answer is 7. So that is how we evaluate this expression. We don't evaluate 5 plus 8 first and then divide 13 by 4. We don't do that. Now let us look at again this expression 12 divided by 6 star 3. So again there's no parenthesis here, so we need to be able to say which operator has more precedence. So now here the previous example we had plus and division, addition and division. So if that's what we have, then division is given more importance. If we have division and multiplication, both actually have the same level of precedence. So if they occur in an expression like this, we have to break the tie by evaluating the expression from left to right. So that means we have 12 divided by 6 star 3. So that means this division is occurring first when you look from left to right. So we have to do that division first, which is 12 divided by 6 is 2. So again, when you do this division, we take only the quotient. Okay. So then 2 star 3, which is 6. You might have come across integer division. That's what we have here, 2 integers. So the result of an integer division is just a quotient. Alright, so now if you have the expression somewhere where you have both division, all the 4 actually, division, multiplication, and then a minus and a plus, all the 4 symbols. So if that's the case, we need to know again the rule. So multiplication and division have higher precedence. So here I have written 1, 2, 3, 4. So number 1 is the highest precedence and number 4 is the lowest precedence in this rule. So now in this expression, third expression we have here, we have only the math symbols. So multiplication and division have more precedence compared to addition and subtraction. So now we have both multiplication and division. So we need to break the tie in favor of the operator that comes from the left. So we have star appearing first and then the division. So we'll do 4 star 5 first, which is 20. Then divided by 2 minus 7 plus 3. So now we still have division, subtraction and addition, but division now gets more precedence, and so we do 20 divided by 2, which is 10, minus 7 plus 3. So now when you have addition, subtraction only appearing here in expression, both addition and subtraction have equal precedence. So we just break the tie by evaluating from left to right. So we'll do first 10 minus 7, which is 3, then plus 3, which is 6. So this is how this expression is going to be evaluated. Okay. Now if your expression has some parentheses as well as this operators, how it's going to be evaluated? So according to our rule, parenthesis has the highest level of precedence. So if an expression has a parenthesis, we will evaluate that sub expression inside the parenthesis. So here you see you have 4 star and then a parenthesis and then this. So even though you see a star here, and among the 4 arithmetic operators, star has the highest precedence, we don't evaluate this star first because there's a parenthesis, so you want to evaluate whatever is inside the parenthesis. Now again, inside the parenthesis we have 5 star 2 minus 7 plus 3, all sort of operators, but there's also a parenthesis which is enclosing 2 minus 7. So again, the parenthesis, whatever, so we start from the outer parenthesis and then keep going inside and evaluate the innermost parenthesis first. So we will first evaluate this 2 minus 7, which is negative 5. So now the expression inside the parenthesis becomes 5 slash 2 minus 5 plus 3. Now slash is the division, so we'll just take the quotient. 5 divided by negative 5 is negative 1. And so I just put this parenthesis here just for our understanding. We don't really need to put, we can just say negative 5 here. So that's not a parenthesis really. So 5 divided by negative 5 is negative 1, then plus 3. So why we again evaluate division first? Because we have division, addition, and division has more precedence than addition. So that's why we do 5 divided by negative 5 first. So that's negative 1, now plus 3, which is still inside the parenthesis, so we don't still evaluate the multiplication now. So we do negative 1 plus 3 is 2, and that's the value now coming out of this parenthesis. So we can now do 4 star 2, which is 8. So that is how we evaluate expressions involving operators, arithmetic operators. So this 4 examples here covered basically 1, 3 and 4, but we didn't have an exponent case here. So after a parenthesis, if an expression has an exponent, that is given more importance and is to be evaluated. So now when you have an expression with exponents like this, so there are 2 exponents here, 3 exponent 2 exponent 4, that is 3 raised to 2 raised to 4. So if you have more than one exponent, okay, so how you evaluate such an expression with multiple exponents? So if you have multiple exponents, we do break the tie from right to left. So we do 2 raised to 4. 2 raised to 4 is 16, and then we do 3 raised to 16, which is this number. So you may think about what is the difference in evaluating exponents the other way. If you evaluate the exponents the other way, it will be 3 raised to 2, which is 9, and 9 raised to 4 is not equal to this number. Okay, so you can cross check. So there's a difference in how will you evaluate exponents from left to right, or you evaluate exponents from right to left. So this is some basic things in math you should have come across. Now we will use these rules to kind of look at how we can write a code to evaluate an expression. Okay. So now whatever we have seen so far are regular expressions like this. From a terminology point of view, we can call this as an infix format of writing an arithmetic or math expression. So 2 plus 3 is what we typically that's the format we write to add 2 and 3. So it's more formally called an infix format for an expression. There are a couple of other formats called prefix and postfix. So what is the difference between these 3 formats? Now in the infix format, the operator comes in between, and you may have heard of this term called binary operators. So all these 4 operators, addition, multiplication, division, subtraction, they are binary. So it means they take 2 arguments. So this plus here takes 2 arguments as what is called operand. So what appears to its left is called the left operand, and what appears to its right is called the right operand. Okay. So in an infix format, the operator appears in the middle, and you have the left operand and the right operand. Whereas in the prefix format, the same expression can be written like this: plus 2 and 3. That means the operator appears first, followed by the left and followed by the right operand. So you see, as the name indicates, prefix, so the operator comes first. That's why we call it as a prefix format. So the postfix format, the operator comes at the end. So we have the left operand followed by the right operand followed by the operator. So it's 2. So 2 plus 3 is written as 2, 3 plus in postfix format. So why we need to look at prefix and postfix format? Okay, so in the case of infix expressions, so this is also an infix expression, 5 plus 8 slash 4, or this, everything here is an infix expression written in infix format. So when you don't have explicit parentheses like this, we have to apply the rules here for operator precedence and break the tie and evaluate an expression in fixed format, because an operator an operand could be associated with more than one operator. So for example, this 8 is an operand, right? We could associate this 8 with plus and do 5 plus 8 first, and whatever the result of that we can do divided by 4. So that's one way we can evaluate this expression. We could also associate this 8 with this division and then do 8 divided by 4, and that's what we have to do according to the rule. Then do 5 plus 2. So in the infix expression, we have to use the rules of operator precedence to break the ties. Whereas when you write an expression in prefix or postfix format, any operand will be associated with only one operator, and there's no need to use the rules of operator precedence to break the ties. And we'll see quickly why this is true when we evaluate an expression in prefix or postfix format. Okay. So before we do that, we need to know how to generate an expression in prefix or postfix format given an infix expression. Okay. So if it is just with one operator, we can easily write the prefix and postfix format, like 2 plus 3 in prefix is plus 2 and 3, in postfix is 2, 3 plus. But if your expression has multiple operators like this, how would you generate the prefix and postfix expressions for this infix expression? So that's what we are going to see. So once we know how to do that, we can then evaluate the same infix expression in using the prefix equivalent of it. Okay. All right. So in order to generate the prefix expression, we will have to know how would we really evaluate it as an infix expression if it doesn't have parentheses and everything like this. How would you evaluate it? By using the rules of operator precedence. So if you use the rule of operator precedence, here we have star plus star minus. So we have two stars, multiplication and then addition, subtraction. So multiplication is going to get precedence, and there are two places where you have star, and you can, so it's not a star and a division, it's only two stars. So we can say we do from left to right. So that will be A star B evaluated first, and whatever the result of it, will do plus C star D minus E. So the next thing we'll evaluate is C star D. So put that inside parentheses. So we'll do A star B first, then C star D, then add the result of these two multiplications. So we'll put another parenthesis to indicate that, and then minus E. So when this is A star B is going to be one value, C star D is going to be one value. So one operand integer plus another integer minus E. So that's why we I say we'll break the tie between plus and minus in favor of plus, because we break the tie from left to right. So we'll do this plus this, what are the result of that, minus E. So this is how we would evaluate this expression as an infix expression, right? So that's now sufficient for us to generate now the prefix or postfix expression. So let us first do postfix. So in postfix, according to our rule, the operator comes at the end. We have the left operand, right operand, followed by the operator. So A star B, so go through again the order in which you will evaluate this infix expression. So the first thing you'll evaluate is A star B. So write A star B as postfix. So it's going to be A B star. The star comes at the end and then A B followed by star. Now the next thing we'll evaluate is C star D, so we'll do C D star. So A B star is basically A star B, so one integer plus another integer minus E. So now you will break the tie by preferring plus. So plus comes at the end. A B star is the left operand, C D star is the right operand, and plus is the operator. So that is the expression that we are going to have involving the plus of these two integers. So it's A B star C D star plus the whole thing minus E. That's what we're going to have. So this whole thing is an integer. Okay, so the minus comes at the end. This expression A B star C D star plus is the left operand and E is the right operand. And when you write the final postfix expression, we can skip all the parentheses because we put the parentheses just for understanding to keep track of how would we evaluate this infix expression and the resulting product values. So we can discard all the parenthesis symbols and we can simply say the final postfix expression for this infix expression is A B star C D star plus E minus. Okay. Any questions so far? Okay, so let us continue. Okay, so now what we'll see is how to evaluate a postfix expression and get the final value of that expression. So as I said, the result of evaluating the postfix expression is going to be the same as the result of evaluating this infix expression. So that's what we want to do. Since we don't have parentheses and all this stuff, we don't want to use the rules of operator precedence to evaluate this expression. So we want to generate a postfix expression and then evaluate the expression in that format and get the answer. So for that we'll make use of a stack. So we'll scan this expression from left to right, and if the rule is this, if we see an operand as we scan, push that operand into the stack. So A is an operand, B is an operand, the star plus minus are the operators. Okay, so if you see an operand, push it to the stack. If you see an operator, we need to pop the stack twice. The first item will become the right operand for that operator because we pop the stack when you see an operator. So when we see an operator, we have to pop the stack twice. So what we store in the stack are the operands. So the first operand that pops out becomes the right operand for that operator, and the second operand that pops out becomes the left operand for that operator, and then we will evaluate that operator and put it back to the stack. So let me go through this example here to illustrate the process. So this is the same expression A B star C D star plus E minus. So let's evaluate it. So we scan the expression from left to right. So we see an A. Of course, here I have given some values for the operands. You can use our values also to understand this example, but what we need to know is how to evaluate this expression. So we see an operand, so we push it to the stack. So A is now the only operand in the stack. Then we see another operand, so we push again B to the stack. So this is now after we have looked at A and B. So now what we look here is a star. So that means it's time to pop out the stack. So the first, let me create alright, so we pop the stack. So the first operand that comes out, because we come across the star operator. So the first operand that comes out is this B. So the B is no longer in the stack, there's only A is in the stack. And then we pop the stack again. So as I said, when you come across an operator, we pop the stack twice. So when we pop it first time, the first operand that comes out becomes the right operand. Then the next pop value, the operand that comes out becomes the left operand. So the stack is now empty. So we have got the two operands needed to evaluate with this operator star. So we'll evaluate A star B. So that's going to be one value. So we'll put that resulting product value back to the stack, and that's what I indicate here. So we'll put A star B, which is one integer, and so if A is 2 and B is 3, that's going to be 6. So we'll put 6 back to the stack. So in general, I can indicate that with A star B. So the stack now just has A star B, or the value 6 there. Then we encounter C, which is an operand. So that means we need to push C to the stack. So the stack now becomes something like this. So now we encounter D, which is also an operand. So the stack becomes something like what I showed here. So this is now the stack. A star B at the bottom, C, and then D is in the top of the stack. Now we encounter a star, so it's time to pop the stack. So for the star operator, now the first thing you pop out, it will be this D that will be popped out. So the stack then becomes something like this. The D is no longer there. So we have to pop the stack twice for any operator. So the second time you pop out, C comes out of the stack, so that becomes the left operand for this operator. So now we will evaluate C star D, and if C is 1, D is 5, it's going to be 1 times 5, and we put 5 to the stack. So that's what I indicate here. So at this point, the stack looks something like this. The value 5, which is C star D, on the top, and then 6, which is A star B, at the bottom of the stack. So now we are at this point. So now the next thing we come across is also an operator, which is plus. So that means we have to pop the stack again. So the first thing that pops out is this top of the stack. That becomes the right operand, which is this 5, which is our C star D. And then the second time you pop out, it is A star B. So the stack is actually going to be empty after you do the two pop operations. So now we evaluate A star B, which is 6 plus 5, which is 11, and put the result back to the stack. So the stack will be now just this A star B plus C star D, the value, which is 11. And then you come across E, which is an operand. So you push E to the stack. So if what are the value of E is now on the stack, top of the stack. So then the last thing you encounter in the expression is an operator, which is minus. So you have to pop the stack twice. So this is a minus operator, so you have to be careful. So the first pop becomes the right operand, so that is going to be our E. Then the second pop value is going to be our left operand. That's going to be this A star B plus C star D. So that is going to be 11 minus 4, which is 7. That's the final value. So what we'll do is, again, we'll follow the procedure after. So we evaluated here this minus operator. So after evaluating this minus operator, we'll put the result back to the stack. So the stack will now have just this 7, and there's no more operator or operand in the expression, so we have reached the end of the expression. So when we reach the end of the expression, the stack should have just one item, because that means we have evaluated the entire expression. So we can now pop the stack just once, and the value we pop out of the stack is the value of that expression. Okay, so this is how we evaluate a postfix expression. So let me again quickly repeat it. So for your programs, actually we will not input the infix expression, so you will do this conversion by hand in a paper and generate the postfix expression, and you will input the postfix expression as an input, as a string to a program, and we'll see the code for that soon. So then we will scan this string from left to right. That's our postfix expression. So that's why we looked at string processing, string tokenization, and all this stuff. So we need to extract the tokens from the expression and process them as operands or operators depending on the case. So how will you evaluate? So scan from left to right. The rule is very simple. Use a stack. If you come across an operand which is values like this 2, 3 or anything like that, which is an operand, you push that operand to the stack. If it's an operator, you have to pop the stack twice. That's the rule. And again, we need to know, like when you pop the stack twice, the first pop becomes a right operand for that operator, and the second pop becomes a left operand for the operator. So why I emphasize on that? This is the rule for postfix expression. So if you evaluate a postfix expression, the first pop becomes a right operand and the second pop becomes a left operand. When you look at the prefix expression, it's going to be the other way. The first pop becomes a left operand and the second pop becomes a right operand. So that's why you have to be careful. So in postfix, the first pop is the right operand and then the left operand. So in this case, when you look at from left to right, A is pushed to a stack and B is also pushed to a stack. Both are operands. Then we encounter a star, so it's time to pop out the stack twice. So the first pop becomes a right operand, so it's going to be star B, and then A becomes left operand, so it's A star B is what we're going to evaluate, and that's going to be 2 star 3, which is 6. So we push back that 6, that numerical value, back to the stack, and then we encounter a C, which is an operand, which is a 1, so we push it to the stack. And then D is also an operand, so it's 5, so we push it to stack. Then the star, which is an operator, so we have to pop the stack twice. The first pop becomes the right operand, so it's going to be star 5. The second pop is going to be C, is becoming the left operand, so C star D is what we are evaluating. So 1 star 5 is 5, we push it back to stack. So stack has now 6 and then 5. 5 is in the top of the stack. Then this next symbol we encounter is plus. So we pop the stack again twice. The first pop becomes the right operand for the plus. The second pop becomes left operand. So we will be doing A star B plus C star D, which is 11. And we push that 11 to the stack. So stack becomes empty after these two pop operations. So we push the result 11 to the stack. And then the next thing you come across is an operand, so you push it to the stack, which is this E, the 4, and then minus, so you have to pop the stack twice. So the first pop becomes the right operand, minus 4, then second pop is 11, so 11 minus 4 is 7, and you push it back to the stack, and then you have reached the end of the expression, so you have to pop the stack just once, and whatever you pop out becomes the final value of the entire expression. So you can substitute these values for A, B, C, D, E in this infix expression and use the rules of operator precedence and evaluate that expression as if you want for practice or cross-checking. You'll also get 7. But as you see here, and when we evaluated this postfix expression, which is this, we did not use anywhere the rules for operator precedence to break the ties. Okay, so we just evaluate because each operand with A, B, C, D, or E, or the intermediate expressions, the product or values and stuff like that, were associated only with one operator. Nowhere an operand was associated with more than one operator. So A and B, we have to do this multiplication. And then C and D, they have to go through the multiplication. And then the result, A star B and C star D, have to go through the plus operation. And then E has to go through the minus operation. So even though it is associated with the plus is there to the left of it, what it goes through is the minus. So each operand gets associated with only one operation. Okay, so that's the characteristic of prefix or postfix expressions. Right? So any questions so far? Okay, let me save this as a video.